Hey everyone, welcome back to the Foundations in Pre-Calculus 10 videos. In this video, we're going to look at Lesson 2 from Chapter 2, which is looking at using the tangent ratio to calculate lengths. So just as a quick recap from our last video, when we're working with an angle, the opposite side and the adjacent side in a right triangle, we can use the tangent ratio to solve for any of those three things. So looking here at a right triangle here, and suppose we had an angle theta here down at the bottom. So your side that is opposite to the angle goes across from that angle. So this one here is the opposite. And then our adjacent is the side that's connected to that angle, but is not the hypotenuse. So down here would be our adjacent. So then according to the tangent ratio, that says that the tan of theta is equal to your opposite side divided by your adjacent side. So in terms of opposite over adjacent, there we're looking at the lengths of those sides. So using this ratio, we can find any of those sides or the missing angle just by manipulating our formula. And we're going to look at manipulating our formula to calculate the length of a triangle. And this here is example number 2 from your notes. So here we're going to determine the length of Vx to the nearest tenth of a centimeter. So we're talking about the length of Vx. That goes from the vertex V to the vertex X. So that's for looking at this side right here. And I can label that side X if you like. It can really be any kind of letter that you like. Just typically in terms of math, our first letter that we choose is usually X. So then what I'm going to do is I'm going to label the sides of my triangle, because that'll be really important. First of all, in determining which ratio we're going to use when we get to those more complicated ones, or I guess when we start throwing some more at you, but also to help you figure out where things go in your formula. So right here, this 42 is our angle, and then across from that angle is side 7.2, and it's across from your angle, which makes it the opposite side. Side X, or as we know it as Vx, here is connected with that angle, but is not your hypotenuse, which makes it your adjacent side. So here you can clearly tell that we're using the tangent ratio because we have our opposite adjacent and we're working with an angle. So I'm going to start by writing down that formula there. So tan of theta is equal to your opposite over your adjacent. So in this case here, we know the angle theta is 42 degrees and the opposite is 7.2. Since we don't know what our adjacent is, we can leave that as X. So in this case here, we need to manipulate our equation just to make sure our variable is in the top part, or I guess in our numerators. So what we can do here first is we take our tan 42, if we write this over 1, then we can see that we have two fractions that are equal to one another, which means that that's proportions. And with proportions, we can use cross multiplication to solve. So we have tan of 42 times x, which I'm going to write as x times tan of 42. I typically always write the variable out in front so that way we don't get it confused with the ratio itself. And then that's equal to 1 times 7.2, which is just 7.2. Now that x is in the top, now we need to work on getting it by itself. So the operation that's happening here between x and tan of 42 is multiplication. So to get rid of tan of 42, we're going to divide it. Because this here is an equation, what you do to one side, you have to do to the other side. So tan of 42 cancels out tan of 42, so we're left with x is equal to, so 7.2 divided by tan of 42. So then our very last step here is that we can throw this into our calculator. And just as a quick reminder, don't forget that when we're working with the tan ratio, or really any of our primary trigonometric ratios that we're going to learn in this chapter, you have to make sure your calculator is in degrees. So typically in your calculator, you'll either have a capital D, RG, or even a capital D, E, G. One of these three things mean degrees, so then you're good to go to put this into your calculator. But if you see something that starts with an R or even a G, those are not the correct units that you should be working with. So you're going to get a calculator error. So make sure your calculator is in degrees before doing any calculations. So when you put that into your calculator, and just as a reminder, we're going to the nearest tenth of a centimeter. Here we should get, rounded, is 8.0 centimeters. You should end up with a 7.99 in your calculator, and then because we're rounding to one decimal point, it rounds to 8.0 centimeters. This one here is also not a word problem, so we don't have to write a sentence. But what we should do, though, is because it asks us to find side VX, we should change X to capital V, capital X. So Vx is equal to 8.0 centimeters, or even just 8 centimeters. So that is everything here for this video. If you guys have any questions, make sure to come see me in class or text me on Remind 101. And thank you so much for watching.